Hey everyone, Robert here, back for some Linux and a coffee, and just wanted to tell you that I finally had success with getting my DMZ up and running, and I had started, let me tell you, this is the third video I have done on this. I didn't post any of the other ones because I've kept changing my strategy and changing what I was doing in the network closet. I started off creating the Linux router out of the new machine that I showed you in one of my previous videos, and got that up and running. Everything was set, and looking back at the video when I was editing it, the screen, I had a monitor up so you could see me installing the software and all that stuff, and you couldn't see the screen because it's Linux, so it was just a black screen with white text in the terminal, and it really came out terrible. So and it took a little bit of time, so I really didn't want to relive all that again. So I trashed that, and then of course, if you want to see how to do that, how to install the software packages and the Linux server and all that stuff to get your router up and running, I have another video on that. You can search my channel for it, and it really goes into great detail on how to do it, and there's a follow-up video after that on how to configure Bind 9 with Webmin and all that good stuff. Tells you how to set up your DNS and everything. So if you want to get up to the point of getting your machine ready, you probably could just go back and refer to those videos. But anyway, so there wasn't really anything exciting or new in me showing another video on creating a Linux router, so I went ahead and bypassed that step. I just didn't feel like it was worth wasting your time on all that. So, and then the second video I did, I had come up with a solution because the first time I attempted this, it appeared that running the second machine in the rack there in the network closet was creating too much heat. So I was afraid the machines were going to overheat, and that would be a problem. So I came up with a virtual/physical solution where I had attached another virtual NIC to both of my mail server and web server, and then bound those to the physical NICs on the ESXi host, and then I ran one to each switch for two different subnets. But then I started thinking, well, yeah, it's somewhat a DMZ, but it's not, because the servers themselves were actually attached to both networks, and even though I could manage them through my home network, and the only incoming traffic allowed was through the other subnet, it was a separation of sorts, but it wasn't an actual DMZ, so I wasn't very pleased with that. It worked well, but it wasn't what I was looking for. So I trashed that. And then I tried the other machine again, put it in there, got it up and running, let it run for several hours, was checking core temperatures and stuff on both the routers, and everything seemed to be hovering around 40 degrees Celsius, which is a good operating temperature in my opinion. It could be lower, but I'm not gaming or doing anything real intense on it, and as long as the temperatures aren't rising, because once you get up to over 70 degrees Celsius, then you're getting into some dangerous territory there. So 35 to 40, I can deal with that as long as they stay there, and they have so far. They've been running all night, and everything, and I've tested them through a load with a lot of packets coming in and out, and they raise a little bit, but not much, just a few degrees, then they settle back down. So I know that the exhaust in the closet is working properly. because the temperatures aren't continuing to increase. They'll go up during a load and then come back down, so I know everything's it's getting good ventilation. So but I got it hooked up. I got the DMZ router. It's running. It has the web server and the mail server on it. And what else is running on that? Currently my work computer is running on the DMZ. I'm going to move that over to the secure internal router at a later time, but I had to work this morning for a little bit, so I just left it where it was at on that switch for right now. But it's still secured behind the firewall and everything else. It's just on the edge router instead of the internal router. So, and then I come off of that switch from the DMZ and run directly into the internal router, and it's got a harder firewall on it, and the firewall only allows what's necessary. There's no open ports, anything like that. I've done in-map scans. Everything's closed, so it's the way it should be, and it runs out to all of my internal machines, my wireless access point, my 16-port switch that has all the internal devices connected to it and everything. So I have 2 layers of security there now. I have the DMZ, which of course is firewalled, and then if anyone were to actually penetrate that first layer of security and they were to scan the network, they would see the second machine, the second router is just another machine on the network, but only as one. They wouldn't be able to tell that behind that sat a whole host of 15, 16 other machines and devices that were attached to that. And at that point they would have to penetrate the other firewall in order to even be able to get into there. So I've got a real secure setup here now. I'm going to go through some stuff. I'm going to take you in the network closet, show you the patch cabling and the routers and the switches and all that, and show you how I have that set up. And then I've made a diagram. It's a lot nicer than the whiteboard stuff here. I actually made it with Illustrator, so it looks good, and it'll show you the layout of the topology of all this. So let's go in the network closet and I'll show you what's going on in there. Okay, as you can see, we're here in the network closet now, and I wanted to kind of show you the topology of how all this stuff is cabled together and all that good stuff. Here's the 2816 and the 2708 below it. The 2816 is the secure LAN switch, and the 2708 is the edge DMZ switch. The top router is the DMZ router, and the bottom router is for the secure LAN. So the cable modem here, it comes in, of course, from the wall, and then it goes out and it goes into the main interface on the DMZ router. So it gets its public IP direct from the router, and then it goes out and into the DMZ switch here by the red cable. It's the one coming into the switch, and then from the switch in port 1 here, this first dark blue cable comes out and plugs into the main interface, the ETH0 on the secure LAN router. So instead of the LAN router receiving its public IP from the modem, it actually receives one from the DMZ router. So it's assigned an IP statically through the DMZ router. So according to the DMZ router, The LAN router is just another machine on the network, but of course they're both firewalled, and so any traffic trying to come in to the LAN router from the DMZ is prohibited. Established and related and outgoing connections can go out of the LAN router through the DMZ to reach the internet, but not vice versa. So if someone were to penetrate this first layer of security into the DMZ and run, say, an Nmap scan or something like that, they would only see this other router as just another machine on the network, and all of its ports are closed, so it can't access anything. Now, also on the DMZ, this yellow cable is actually going to my work PC right now, which is okay for right now. I had to work this morning, so I went ahead and left it connected here, but I'm going to migrate it to the LAN router probably this weekend sometime, and I'm going to attach it to its own interface on the LAN router with its own subnet, so it'll actually be divided from the LAN network as well. But and then this dark blue in here in port 5 is going to the ESXi host, and here is where the web server and the mail server are virtualized, and they have IP addresses from the DMZ router, which have been NATed and forwarded to the public internet, so the sites can be accessed publicly. Then as we move to the LAN router, the secure side, the white one is going to a power line adapter that goes downstairs to my smart TV for internet access. The light blue one here is going to the wireless access point, so DHCP addresses and DNS and all of that can be served from the LAN router to the wireless clients. And then this light blue one over here is going to my BSD NAS for Free and Plex Media server. It's my storage array, and it's only accessible by the internal LAN. This other dark blue in here in port 3 is going to management for the ESXi host, so it's only accessible for my internal LAN, and I've actually set firewall rules on the incoming connections of the ESXi management host to only allow connections from this subnet, and several services have been only allowed from this subnet as well, SNMP and several others, just to secure that down a little tighter. And then this one in port 1 here is my home PC. It's my main workstation here at home. But that's pretty much the setup of how I did it. Basically just going into one router, into the switch, and then out of the switch into the second router, and then out of that router into the LAN switch that goes to my secure network. And it works real well. Something I'll tell you, if you're going to do a setup like this, you want to be able to communicate to the services running on your DMZ. Like you want to be able to access your website and your mail server. Like your mail server definitely needs to be accessible from your internal LAN as well as publicly. Like I have my mail set up on my iPhone, so in order to access my email outside of my home, I have to be able to access it publicly, but then when I get home and I want to access it through Thunderbird on my personal computer, I also need that access. So the way you want to set that up is on your LAN router, you want to be sure that the public interface, the one that's connected to the DMZ, is actually masquerading all of the communication to where when you communicate out, it translates to the DMZ as the IP assigned to the interface, so it thinks that you're communicating from that same subnet, and vice versa. When the communication comes back through, it'll masquerade. So the same way you would set up your DMZ router, you have to masquerade your IPs from the public internet in order to communicate out on all of your LAN machines. So basically you just set them up exactly the same, except your LAN router is receiving its IP from the DMZ router, and then you have to have DNS on both machines. DNS on the DMZ for serving IP requests for the web server and the mail server and anything else you have running there, and then a private DNS for your internal machines, and they'll translate between through masquerading. Also, I'd like to mention on my management port here I have a few other VMs running that are only accessible internally. Like I have a Windows 7 machine that I use, I remote desktop into it for if I need a Windows 7 machine for something, as well as an Ubuntu desktop machine that I also access remotely, and our YouTube test server resides on that as well. But that's pretty much all I have for that. I just wanted to show you how the topology was set up and how everything was connected. Like I say, the temperatures and everything seem to be steady, hovering around 40 degrees Celsius or below these little exhaust fans. They are putting out a little bit more heat now than they were, but not a whole lot. So I think it's going to work out real well, and I feel a lot better about it now that I've got everything secured and locked down on the internal side. So if you're running services like a web server or mail server, it's pretty important, if possible at all, that you not run them to where they can access your internal LAN. It can be very dangerous if somebody hacks your web server. Then you have access to your whole internal network, and all your private data and everything is at risk. So anyway, I finally got this set up, and I wanted to show you. I have a diagram here that I built in Illustrator, like I said, that I want to show you. Kind of lays out the topology a little better for you. So let's go over there and we'll take a look and see what you think. Alrighty, here we are looking at the topology diagram that I created here of the network, and let's see here, we'll zoom in here a little bit, and here is the main connection coming into the cable modem, and then it's going out through DHCP into the DMZ router, and it's on this subnet, and then it comes out of that router into the 8-port switch, the DMZ switch, and that switch is assigned an IP on that subnet, and then from that switch it goes into the ESXi host, which is running the web server and the mail server. Okay, then on a second interface on the ESXi host is going out into the 16-port switch, and it's on a separate subnet, and it's the one that I use for management and some internal VMs. So it's the ESXi host is basically attached to both switches. I've thought about moving everything directly to the DMZ, but in ESXi I configured the ESXi firewall to only allow connections in from this subnet, and like I said earlier, several services on the host itself have been restricted to this subnet as well. So I feel pretty safe about that. But carrying on, we come out of the 8-port switch, the DMZ switch, with an IP assigned to the LAN router. So the WAN in on the LAN router is coming from this router, and then it comes out of the LAN router into the 16-port switch, and from that switch it's going to my file server, the NAS and Plex Media, and the power line adapter comes out and is attached to my TV. And also on that secure LAN is the wireless access point, which goes out to all of my Wi-Fi devices. And there's quite a few of those: laptop, Kindle, printer, iPhone. There's quite a bit of stuff attached wirelessly here. And then also attached to that is my home PC. And currently this is the way that I want that I'm going to set it up this weekend. I'll move this machine here, but I'm going to come out of the second LAN interface on the LAN router to a separate subnet just for my work PC. Currently the work PC is attached to the DMZ switch, but I'm going to move that over here just to separate it out from the web server and the mail server. But anyway, that's pretty much how it's all laid out. I just wanted to kind of show you this diagram here so you could maybe see a little more of how it's all laid out. I'm constantly changing and doing different stuff, so there's no telling where it's going to wind up at. But for now, this is a good setup. I think it's pretty secure. I feel comfortable with it, so I'm going to stick with this for a while and see how things go. Remember also that the DNS is running on both machines. So DNS here on the DMZ router has these clients set up in it and hosts, and then it has the LAN router has all of these hosts set up in there, and then this WAN port is masqueraded into this subnet and back and forth, just like this DMZ router is masqueraded out to the public internet. So you have to masquerade those ports, or you're not going to be able to talk to your DMZ. So I can communicate out of the LAN router into this switch here and talk to anything attached to the DMZ, provided that I have DNS set up. Well, I mean, you could even access it by IP address, but everything on my network has its own host name. So if I want to say access the Webmin interface for the DMZ router, I can just type in its host name in the web browser and log right in. Same thing with the switch or the mail server, the web server. I can SSH into those from my internal LAN, and I'll show you. Let me bring up a terminal here and I'll show you some of the firewall rules that I have set for some of this stuff. Maybe help it make a little more sense. So let me get a terminal open and we'll take a look at that real quick. Okay, so actually I decided to just open up Webmin instead to show you the iptables rules that I've set. This one here that's up on the screen is for the DMZ, the edge router. Right now we're in the packet filtering table, and this is for the input chain, and this is any packet that is addressed directly to the host, so that means anything coming directly in from the public internet. Of course, I have first rule set to accept loopback connections, and then this drop rule is just a malicious IP that was nailing my router. It looked like to me they were doing an nmap scan or something, so I just dropped them at the firewall right on the edge so they can't contact anything on the server. And it was filling up my log files, so I went ahead and just dropped it so it wouldn't log, because the last rule here is to jump to the logging chain, and I don't want to log all that junk. So, and then if the input interface is ETH1, which means any machine on that DMZ communicating out through ETH0 or into the router from ETH1, we're going to accept that. And then any connection coming in to ETH0 from the public internet, as long as the connection is already established or related to an established connection, then we're going to let that through as well. And then the last rule, anything that doesn't match one of these 4 rules is going to jump to the logging chain, and that's the chain down here that I've added, and it's set on ETH0 to log as long as the rate is less than 5 per second, and burst rate isn't over 10, it's going to log that packet. Otherwise, it's just going to go down to the next rule and drop that packet. So, and I do that connection rate on this rule to keep log files from filling up. You know, if somebody's trying to DDoS the router or nmap scans, stuff like that, it may log some, but if they're just, you know, nailing it like crazy, it's just going to drop those packets. It's not going to worry about logging them. And then here, since it's a router, forwarding is enabled, so communication is allowed to pass through the host. So on the forward chain here, I've accepted connections as long as they're coming from ETH1 and going out ETH0, meaning anything on that DMZ contacting DNS or trying to connect with a website or a service externally is going to allow that through as long as the connection originates from inside the LAN. And then the same rule like I have for the incoming packets. If there's a packet coming in from the internet and it's destined to go to a machine attached to ETH1, it's only going to allow it to go through if the connection's established or related. So unless one of those machines initiates a connection, that traffic coming back in is not going to be allowed to. And then these last 2 rules are forward rules for the web server on port 80 and the mail server on 995 and 25. That's POP3S and SNMP, so, or SMTP. So I don't have a 465 or 587 because I don't use my mail server to send outgoing mail, and I'll tell you why. Is because I found out that my ISP actually puts their dynamic IP blocks on a spam list. So because any of their client IPs that they issue through DHCP are not authorized to be sending mail from that IP. The only mail that's supposed to be sent from their IPs is supposed to relay through their mail servers, so which have their own IP. So the way I got around that is I just basically disabled outgoing, which definitely secures the chance of anyone trying to relay spam through my server. and then I just use my ISP's outgoing mail server to send mail. So any incoming mail going to my self-hosted domain comes in just fine. Anybody can send me mail to that address because I have my DNS with my domain provider set to my public IP address. So anyone sending that mail, it's going to come through just fine. And then if I want to send any out, it'll just relay through my ISP and all is well. That way I can just go about my business, whether I'm using my iPhone across the world or if I'm using my Thunderbird client here at home. Doesn't matter. I've got all that set up to relay through them, so I'm still using a legitimate mail server to or an authorized mail server, I should say, to send that mail. Now, these forward rules, I have a video on setting up port forwarding and NAT for Webmin, and I also go over how to do it in the terminal. So search for that video if you're wondering how to do this, but I'll show you real quick. If we go up here in iptables and we go to the NAT table, here I have my destination NAT rules set up for those servers. And it's real simple. You just tell the destination NAT to send anything that matches these credentials down here. It's going to send that packet to this IP address on this port. So I just set it to if the incoming interface is ETH0, which is the public internet, and if the protocol is TCP port 80, then it's going to send it to this IP address. But that's not enough to get that forwarding to work. You still have to tell the firewall to allow that traffic to pass through the host. So that's where you put in your forward rule to allow that if the destination is that IP of the server and it's destined for port 80, it's going to allow that traffic to pass. So that's how you set up the forwarding on it. But now my internal LAN firewall is set up basically the same, except it doesn't have any NAT rules and it doesn't have any forwarding rules other than the ones you see here, just for communicating from the LAN out to the public internet and from the public internet into the LAN if it's an established or related connection. So but something else I'll show you here, masquerading, you have to be sure that you masquerade your ETH0 or your public interface, unless you just have one machine on the network. If you only have one machine on that interface, then you should be fine. But if you have a switch and several machines or more than one machine, you're going to have to masquerade that traffic or it's not going to be able to communicate. So that's basically all I have really to show you. I just wanted to show you that I got the DMZ up and running and a little bit of the topology and some of the firewall rules. I do have Webmin on both the DMZ and the private LAN, but they are only accessible from specific IP addresses within the LAN. The DMZ router is only accessible from the interface that's attached to the LAN router, so nobody can even log into it unless they're coming directly from that IP. So I feel good about all of it, and I wanted to share with you. I'm sorry I didn't get the video of me actually creating and installing everything on the router, but I have another video of me doing all that, so you can, and it's a lot better video than what this other one would have turned out like. So you might want to check that out if you're interested in a setup like this. But anyway, that's it for now. So give me a thumbs up. Let me know what you think about the setup, and I wish you the best in your networking endeavors, and more Linux and a coffee to come later. So don't forget to subscribe so you can check out the new videos, and until then, y'all have a good day, and I'll talk to you later. Bye-bye.